Alright, today we're going to talk about 5.3 and 5.5 factoring. We've already done a few things out of 5.3, but this is going to be something new. So we're finally going to start our factoring. So we're going to talk about the two easiest types of factoring today. But before we do that, let's talk about what factoring actually is. And just a forewarning, you guys are going to have to bear with my messy handwriting. I do not have a stylus at home. So I'm drawing with my fingertips. So it's not going to be the greatest. So just, like I said, bear with me. So we have been doing problems such as 3x times the quantity, 4x plus 5, and we would distribute the 3x, and we would get 12x squared plus 15x, right? We've been doing that for a long time now, okay? So this is multiplying, okay? Nothing new, right? So if I wanted to go the opposite direction, if I wanted to take an expression that looked like 12x squared plus 15x and turn it into something that looks like 3x times the quantity, 4x plus 5, this is where factoring comes into play. So factoring, a way I like to think about it, factoring is kind of like the opposite of multiplying. So we have a lot of inverse operations, multiplication, division, addition, subtraction. So when we talk about multiplication as far as polynomials go, the inverse of multiplying polynomials is factoring polynomials. So that's what we're going to do today. Okay, so the first kind of factoring that we're going to learn about, and the kind that you will use most commonly, is factoring out a GCF. Like I said, I apologize for my handwriting. I'm doing my best. So factoring out the GCF, or the greatest common factor. Okay, so just to kind of look at an example while I talk about steps, we're going to factor out the greatest common factor of 16a minus 18b plus 12. Okay, so this is really the first thing that you should check for anytime you're asked to factor. So what we're going to look for is if we're going to factor out the greatest common factor, I have to find my greatest common factor. So I have three terms. So I'm going to look at my three terms and I'm going to ask myself, what is the greatest common factor between 16a, 18b, and 12? And some may be easier than others, but if we think about this, well, they don't have a whole lot in common. The only thing they actually have in common is a 2. So you're going to find the greatest common factor, and you are going to write that down first. Once you find the greatest common factor, you're going to open a set of parentheses. Now, since I said that factoring is kind of like the inverse of multiplying, if I were to distribute this 2, I need this expression back. Ultimately, it has to be equivalent, okay? So if we think about distributing this 2, if I were to distribute this 2, I would be multiplying by something, and it has to equal 16a. So let's think about this. I need to find something times 2 that gives me 16a. And so if I plug in an 8a there, well, let's think about this. 2 times 8a gives me my first term of a 16a, and I have to have that original expression back. Okay, so we're going to plug an 8a in. Okay, so then let's think. For my middle term, I need a negative 18b. So I need to find what times 2 gives me a negative 18b. And hopefully you're thinking, okay, well, I need a negative 9b. And then for the last term, I have to ask myself, 2 times what will give me that last term of a positive 12? And hopefully you can figure out we need a plus 6. So once again, remember, if I were to redistribute this 2, I would get 16a minus 18b plus 12. It should match. And then one way you can always check your answer, you can distribute, and then also, if you really truly factored out the greatest common factor, anything inside the set of parentheses shouldn't have anything left in common. 8a, 9b, and 6, they don't have anything else in common, so I know I factored out the greatest common factor. Okay, so let's look at some of these examples. Okay, first one, I want to factor 15a plus 25b plus 20. Okay, so remember, I need the greatest common factor between all of my terms. So 15a, 25b, and 20, only thing they have in common is a 5. And so now I'm thinking, if I were to redistribute that 5 times what would give me that 15a? And hopefully you guys can come up with 3a. Okay, and then if I were to distribute the 5 to my middle term, I need a 25b. So the only thing that could go there would be a 5b. And then finally, if I were to distribute the 5 to my last term, I need 20. So 5 times 4 will give me that last term that I need. Okay, let's look at another one. If we have 7y cubed minus 21y squared minus 14y. Okay, so thinking about our greatest common factor, let's look at our numbers first. I have a 7, 21, and 14. So the greatest common factor between those three terms would be a 7. Okay, so remember, we next need to look at our variables. So I have a y cubed, y squared, and y. I want to know how many y's do they have in common. And if you remember doing that from a few days ago, they only have one y in common, so the greatest common factor between those three terms is 7y. And then this is the same thing. If I were to redistribute that 7y, I need this exact expression back. So to fill in my blanks, 7y times y squared will give me my 7y cubed. 7y times a negative 3y will give me the negative 21y squared. And then finally 7y times a negative 2 will give me the negative 14y that I need. One way when it comes to the variables that I think about, I'm factoring out a y, right? This first term had 3 y's, so think of it in terms of what's left. Well, if there was a y times a y times a y, and I took away one of them, there should only be 2 left. So sometimes when I think about factoring out a variable, I think about, okay, if I'm going to factor out one y, how many are left? For the middle term, I had a y squared, and if I factor out one of them, well, there's only one y left. Sometimes I think it's easier to think about it that way. Okay, let's look at a couple more. Let's say we have 15x squared y squared minus 6xy squared. Okay, so once again, find the greatest common factor between your numbers, 15 and 6. The greatest common factor between those numbers would be 3. Look at your x's. I have an x squared and an x, so they only have one x in common. And then I have a y squared and a y squared, so they have a y squared in common. Okay, so if I were to redistribute that 3xy squared, 3 times 5 will give me the 15 for my first term. Now think about it like I was just talking about. I factored out an x. For that first term, I need an x squared, so I would have 1x left over. Now, for the y's, I factored out y squared, and in that first term, I had y squared. So I don't need to have any y's in that first term there, because if I were to, once again, redistribute that 3xy squared, it would give me 15x squared y squared that I need. Okay, and then for the last term, 3 times negative 2 will give me the negative 6. I had an x, and I factored it out, right? And I had y squared, and I factored it out as well. So it should just be a minus 2. Okay, and last one of these, number 4, 48a cubed b squared plus 72a squared b cubed. Okay, now this one could be a little more difficult to come up with the greatest common factor if for no other reason than the 48 and 72. They have a lot of factors in common. They have a 2, a 4, a 3, a 12. But actually, if you do some digging, the greatest common factor between those two numbers would be 24. And then if you look at the a's, I have an a cubed and an a squared, so I can factor out an a squared. They have a b squared and a b cubed, so I can factor out b squared. So my greatest common factor is 24a squared b squared. And when I factor that out, you should be left with 2a for the first term and 3b for the last term. Okay, so this is the first type of factoring, the most important type of factoring, and you will use it over and over and over again. Now, the second type of factoring that is really, really easy is factoring difference of squares. We will get into some of the more complex type of factoring after Thanksgiving break, but this is the easiest type of factoring other than the greatest common factor. So let's talk about what this is going to look like. So let's go back to the idea of if factoring is the inverse of multiplying. So let's look at multiplying these binomials, a plus b times a minus b, and let's see what happens. So if we were to FOIL this, I would take a times a, which gives me a squared. I would take a times b, which gives me a minus ab, and then b times a, which gives me a plus ab, and then ab times a negative b, which gives me a minus b squared. Okay, and then if we look further, notice my middle terms cancel out, so I'm just left with a squared minus b squared. Okay, so the reason why we're looking at this is we're interested in factoring, not multiplying. So instead of multiplying, FOILing using the box method, I want to be able to take an expression in the form of a squared minus b squared and turn it into a factored expression that looks like a plus b, a minus b. Okay, now remember I told you this is the easiest type of factoring. So this is called a factoring pattern, and so we're going to use this factoring pattern to factor expressions in this form. So it may sound confusing, but it's really not. So let's look at the expression y squared minus 49. So remember, I want to factor this down. And so what we're going to look for is we're going to see, do I have something squared in the front and something squared in the back? Or do I have something squared minus something squared? Because what we just did by multiplying, we showed that if I multiply an expression that looks like this, I'm going to get something squared minus something squared. So that's what we're going to look for. So we're going to ask ourselves, what squared gives me y squared? And that one's usually pretty easy to fill in. I can take y and square it and it gives me y squared. Okay, for the second one, I want to know what squared will give me 49. Okay, well hopefully we can come up with 7. So what this does, the y is going to be my a, and the 7 is going to be my b. So now we're going to go this direction, and we're going to plug y in 7 and factor it using that form. So I could factor this as y plus 7, y minus 7. Okay, now I know it may sound confusing, kind of hard to digest, but let's think about this. If I were to FOIL this out, I would get y squared negative 7y plus 7y, which would cancel out, and then negative 49. You would get the same thing. Remember, you should always get the same thing back. If your factored expression, if you multiply it out, you should get the same thing back. Okay, so let's try another one. Let's try 81 minus w squared. Okay, so once again, we're going to check, do I have something squared minus something squared? So we're going to ask ourselves, what squared gives me 81? Hopefully we can come up with 9, and then what squared gives me w squared? And we know we can do w. So if you can fill in those two blanks, all you're going to do is you're going to take the first term, add it to the second term, and then you're going to take the first term and subtract it from the second term. So whatever you fill in with those parentheses, you're going to add them and you're going to subtract them, and that is your factored expression. Okay, so let's keep moving forward. These ones, once you get the hang of it, they all are pretty much done the same way. So let's try 4x squared minus 9. Okay, so remember, do I have something squared minus something squared? Okay, the first one could be a little hard to fill in at first, but let's think. I want to square something and get 4x squared back. And hopefully, with a little thinking, if I take 2x squared and I square it, because remember, this means I have to take 2 squared and x squared, it's going to give me that 4x that I need. And then if I take 3 squared, that will give me my 9. Okay, now remember, whatever's in here and whatever's in here, to factor this, you're going to add them and you're going to subtract them. So 4x squared minus 9 as a factored expression is 2x plus 3, 2x minus 3. Okay, let's try 16t squared minus 1. Okay, so we're looking, what squared will give me 16t squared? Okay, so hopefully we can come up with 4t. And then what squared gives me 1? Well, just 1. That one's pretty easy. So if you can fill in those two parentheses, we have 4t plus 1, 4t minus 1. And once again, if you're not sure, remember you can always check your answer. Just multiply it out. Okay. And let's just try 2 more. This time let's do 49z squared minus 81x squared. Okay, so we're seeing if we can fill in these two blanks. So looking for something squared that will give me 49z squared. So 7z squared will do the trick. And then 81x squared. If I take 9x squared, that should give me what I'm looking for. So for this one, we can take 7z plus 9x, 7z minus 9x. All right, and last one here. I take 49p squared minus 25q squared. Okay, so once again, see if you guys can do this one. What squared will give me 49p squared? What squared will give me 25q squared? And hopefully your answer is matching mine. If not, maybe check your squares, make sure that it's all lining up. Okay, so that is all for today. I'm going to go ahead and write down your homework. Alright, well here's your homework for over Thanksgiving break. Hopefully this all made sense. If it did not make sense, I encourage you to look at some of these examples in your book. Maybe ask for help from a friend. Khan Academy has some really, really great videos, so there would be a place to look too. But hopefully you don't even need that because my video was so awesome. But you guys have a great Thanksgiving break, and I will see you Monday, November 30th.